Hello everyone, my name is Orhan Ergun. For those who don't know me yet, I'm a CCA and CCDE. I'm a CCDE trainer, and today I want to share with you a part of one session, 30 minutes, and I will show you how you can come up with different designs for a different design goals. One design goal can be achieved with many correct, with many ways, and one of them most probably is most optimal, and our goal is to find that optimal one. And I will use simple topology, layer 2 topology here, and VLAN design I will share with you. And I just cut one part of one session, and hopefully you enjoy. Thank you very much for watching. Today is the 16th session, and I will start with the topology, and we will see how network design goals can be achieved with different designs, but all of them can be true, but some of them might be more complex than the others, and attribute can change, like more scalable, so on and so forth. And I will show you how it can be done with this small basic topology. Okay, and then we will be talking also, I will remind you, so far in the course what we talked from layer 2, layer 3 perspective, and IGP, BGP, MPLS, all inter provider, multi-domain stuff. And although we talked about in general in layer 2 Ethernet and its control plane, legacy control plane, spanning tree, and from the design exam, because CCDE exam is the concern. Otherwise, of course, we have many layer 2, layer 1 information that we need to be definitely aware in the different place in the network, like service provider, campus, data center, etc. And today we will talk about them a little bit also. But let's start first with this design. The constraint, you have 3 VLANs. Okay, you will use 3 VLANs. You will partition with these 3 VLANs. And just as a reminder, why you are using VLAN in general for 2 purposes, right? For the fluid domain boundary, to put the boundary and to put some hosts, some devices in the same broadcast domain, so you can eliminate the flooding, and their resources can be utilized optimally. Another reason, also for the security reason, you use VLAN, so you can put some boundary, you can put some filters, so on and so forth. And here we will use for both reasons. Here in this design you will see 3 available subnets, and it can be any subnet, of course, but I just gave you 10.0.10/24, 2.0/24, and 10.0.30/24. And now we have some users, right? And these can be, all these devices can be switch, basically. And user 1 to user 20, and blue users. And user 21 to 40 is connected to the switch A, and red users, as you see, in 41 to 60 blue and connected to this one, and 6180, these users, this range of users, okay, 20 users here is connected to here, and passing through all those switches, etc. Then we are going and connect to the switch F, another set of users, blue. This can be the department in the network, let's say, like marketing department, and their user is like separated like this, and another one engineering maybe. Okay, and now we want these blue users, okay, to reach only to this server. This is the server. Our server is here, connected to the switch G, and we want only those users, blue ones, to reach to this server, not the red ones. So based on this, how would be your design, VLAN design? How would you put those users into those three VLANs, and then your design goal is to just make all blue users just available to access to this server, not the red ones. Okay, think about it. How would you do that? You have 30 minutes. No, I am joking. Okay, I'll just start and explain. Maybe, of course, if you have time, you will find what we will talk here. No, it's not a layer 3 VPN or something. These are switches, and these are just users, and you will use VLAN only. And based on your VLAN design, three VLANs you have, like VLAN 10, 20, and 30, let's say, okay? You have three VLAN, VLAN 10, VLAN 20, and VLAN 30, and goal is to make them reachable, just blue users, reachable to the server, not the red ones, and that's it. Okay, so let's think about it. And in general, couple best practice what people consider. Okay, put nearby users, nearby hosts into the same VLAN, and then let's see what would happen. I mean, the user connected to this switch A, if we would put them into the VLAN 10, let's say, okay, then users connected to the VLAN, this one, the switch B, let's say VLAN 20, and this one, the switch F, this user group, let's say VLAN 30. Now, what we want? What we want to do? Blue users to reach, right, to the server only, not the red ones. So if we assign, let's say, VLAN 10, 10.0.1.0 slash 24, then 10.0.2.0 slash 24 for the VLAN 20 for those set of users, and 10.0.3.0 slash 24 for this VLAN 30. Okay, now your filter, okay, let's say you will put a filter here, firewall, whatever, access this. Filter here would be what? You cannot go and say as a subnet level that 10.0.1.0 slash 24 and 10.0.3.0 slash 24. You cannot say that because there are also red users. So the problem, your filter will be huge and based on this individual host levels, right? You need to identify what is this IP address slash 32 of this user 1 to user 20, from 1 to 20. All this user needs to be permitted with here, okay? And then also you need to add this user 81 to user 100. So you cannot do subnet based filtering here. This is the problem. Okay, so this would be your one design option, that you can group nearest hosts, nearest users connected to the same switch, let's say, okay, into the group, and then put the filter on the target side. But the problem with that one, if you have like different user group connected to the different switch, and if you group them together in one VLAN just because they are connected to the same switch, just very close to each other, the problem, you need to go and individually at the host level, you need to put a list, filter list, etc. Your filtering rule will be at the individual host level or host range, but not the subnet level, like /24 and then slash another /24, then fix it. So one problem then, here the size of the filter is huge. But you don't need to put here, let's say on this switch between switch A and switch C, and switch C and switch B trunk, etc. Because now the group of this user is just limited to those VLANs and those, like a routed access design, right? We talked about layer 3 access design. So you don't need to create any trunk, etc. here. Okay, those groups of users there connected to the switch A and switch B, they are in the same VLAN. So let me go to the second option, and this trunk will be much more clear for you. Let me just take this back. Sorry, guys. Okay. Okay, as you've seen what we did for first design option was just grouping the closest one, and we didn't even take these different user group into consideration, like different department in the network. So just closest one, you put them into the same VLAN, and the filter on the target was not the subnet level, because as you see in 10.0.10 was also including these red users, and red user was not allowed to go to the destination server. That's why we need to identify within that VLAN who are the blue users, and we need to just permit blue users. This was the constraint. Then let's try to do this with the not taking the closest same switch, let's say host into the group, but let's put, let's say, like this. This one, okay, what would happen? VLAN 10, let's say, and another color let me use, different one, let's say this one. These red users, VLAN 20, let's say, and let's use VLAN 20, okay, and for this one, VLAN 30, VLAN 10, again 10.0.10, let's say, /24, VLAN 20, 10.0.20/24, and VLAN 30 10 0 3.0/24. Okay, now good. VLAN 10 blue users. Okay, cool. We can put a /24 a filter here. Cool. And also VLAN 30. Okay, also another /24 blue users. And red one we don't want, and they are in VLAN 20, right? But blue ones, for the blue ones, we can just put 2/24, but we cannot summarize them because it's not contiguous. VLAN 10 10.0.1.0/24, and another blue user group in VLAN 30 and 30/24. So in between there is 10.0.20/24. So you cannot do like 10.0.1.0/23. Otherwise, you would be also allowing the red users. So you need to have two different /24, and in comparing with the first design, you will not go and host level, you will not filter at the host levels, but you can do at subnet level. This is good, but you cannot summarize. But actually, biggest problem is not that one. The problem now, not only the number of filters on the target site, but as you see now, you need to pass. Okay, there's this is your trunk link, right? And also now, where is the other VLAN group? Here. You need to pass this VLAN over these trunks, and all these links needs to be that whatever that VLAN needs to be allowed on these trunk links. Okay, as you see now, this VLAN needs to be allowed on this trunk, on all this. Okay, because you will have different VLANs, etc. as well. If you need to pass more than one VLAN on the physical link, you need to create a trunk link, as you know. And problem that one. Now here, comparing with the first design, you can go and do something at the subnet level, but you are not careful to put them into the contiguous block. So it is much scalable compared to first option based for the number of filters. Okay, because /24 level you are doing, not the user host based level. But problem also, number of link that needs to be allowed as a trunk link here is much more. Okay, take a capture, take a photo, because now I'll go another design, then we will compare with the other design. But as you've seen, definitely we can also achieve our end goal. End goal is just we will use 3 VLANs and we have 3 subnet for them. And blue users can reach to the target server, not red user group, okay? And 2 of these design options actually allow the same design goal for us. But there was some pros and cons, right? As you see. In the first one, again, as a reminder, the first one, we just blocked the closest user group into the VLAN. But since in that, let's say VLAN 10, there was blue and red host groups. So we need to identify which one is blue, and then we need to go and on the host level, individual host level, we need to write our filters, number of filters lines will be of course much bigger compared to the second design option, because now we can go and do something at the subnet level. Okay, but here also the problem, we need to allow much more that those VLANs, let's say VLAN 10 here on the end to end, right? And VLAN 30. How VLAN 30 will reach to the server. Okay, cool. Let's go and talk about other one. Okay. There should be another way to remove this. Anyway. So far, do you have question, guys? Now, how would I draw? I don't know, but think like this. Okay, we are now grouping this one, blue users, into here in only one box. Let me take this one. Okay, as you see in one box, and this is now VLAN 10, 10.0.1.0/24, and here the red ones, just the red ones, okay? Let me use the black one. VLAN 20, and this one. Now, once I do this separation, not extending to the VLAN, that's blue user between the switch A and F. If I partition them, I don't need to extend that VLAN end to end. So the trunk link will be much less. I will also put this one into VLAN 30. I didn't write yet the subnet of VLAN 20 and VLAN 30 because so far I was also matching, and this is also another best practice people use, but you don't have to. Addressing schema is very important for the better design and to put better prefix-based link filter lists. Now, in what I was talking about, this is very common, right? If it's VLAN 10, let's say, and your subnet, let's say 192.168, what you do? 10.0. For the VLAN 20, 20.0, right? You go like this one by one match. But let me change this one. 10.0, 3.0/24, 10.0.2.0/24. What will this give me? Now I am not extending for this user 1 to 20 and user 81 to 100. In the second option, I extended those communication end to end. I had to pass that VLAN on those trunks, right? And that was the problem. And here I am not doing that. It's cool. Now, instead of that, I put user 1 to user 20 and user 41 to user 60, which is the blue user group, into the one VLAN, which is VLAN 10, and the subnet is 10.0.10/24. And the red users here, 21, 40, and 61 to 80, into VLAN 20, and now the subnet, I'm not matching one by one like 10.0, 2.0 you would expect, but 3.0.24 I did. This will give me what? First, what will be my entry here, the filter on the target side. I can do subnet base because now what I need to allow, I don't need to go and identify in the what is in the 10.0.10/24 VLAN 10, what is the red, what is the blue, because just blue I have. So /24 level, I can write my list. But if you see in another user group, blue user group is VLAN 30 on this side, is 10.0.2.0/24. Now this is also contiguous. I did. So here my filter entry, just I can summarize even, and I can do like 10.0.0/23, right? That's it. So the one line, one entry would cover my list. I don't need to extend end to end that VLAN from all these physical link on the trunk, right? Uh, and now I achieved actually the end result. But here you can, as you've seen, there will be trunk links that access that VLAN needs to be allowed, which is here, right? And here, because that VLAN 10 is on these switches, between these switches. But as you've seen in the option 2, I had to allow on here as well. But here, on this option, last option, what I am not doing, I didn't extend that VLAN 10 end-to-end, so on the intermediate physical link, I don't need to deal with that VLAN and allowed VLAN, etc. And also the contiguous block, I was careful to allocate the VLAN to the subnet to the VLAN number. So now I can also even further summarize my filter /23, let's say, and that's it. I don't need to deal with the host level filter list like in the first option, as you've seen, just the group, the user connected to switch A into the same user group. But since red users also there, I had to identify what are the blue users in that VLAN 10 connected to the switch A, and then put my filter on the target based on the individual host, but not the subnet level, etc. Is this clear, guys? So end goal can be easily achieved with different network designs, but one will be probably the most optimal, and CCDE will at least try to achieve to find this one, and we'll test you based on this, the most optimal one.